All right, here we go. 12.4. Limits. Limits at infinity. Now, everybody says they can't see the color. Can you? Can you see it? Or is that just no? Okay.
Yeah.
Yeah, you can, but people are saying no, so if you say no, I gotta move on. Limits at infinity means this. Find the limit as x approaches what number? Infinity. Remember I used to say as x approaches 4, what's the limit? Well, we're not going to approach a number anymore. We're going to approach what? Infinity of a function. So, or it could be, it could be negative infinity. Okay? Now, can somebody visualize how this is going to work? Like, how am I going to approach some number as I keep going this way on the x-axis forever?
You don't.
You don't get an answer ever? Well, sometimes you don't, Hannah. You are right. But there are times when you do get an answer. Can you visually think about the graph, how it would look? Here is positive infinity. Here's 10. I know this scale-wise doesn't work. Here's 100. Here's 100,000. Here's a billion. Okay, as you keep going that way, how would the graph look? Now remember, the limit is as you keep going, from the left and the right of a number, you approach some number. 12 is the limit. Or 1/4 is the limit. How is this going to work? Ivy? If you have an asymptote. What kind of asymptote are you talking about? Vertical? Horizontal? She says vertical. Okay. There's a vertical. Ready? I'm going to go this way and up. Okay. As I put in 10, I get this number. 100, I get this number. 100,000, I get this number. Something right about here, I get, now I'm getting a bigger number. So am I approaching some number? What number am I approaching as I go up and up and up? Well, positive infinity forever that way, but that's not a number. So you said vertical. Yeah, you almost had it. It's horizontal. Okay, watch this. Okay. If I was going to positive infinity and my graph went like this, okay, here is a horizontal. There's a horizontal asymptote. If I put in 10, I get out this number. If I put in 100, I get out this number. If I put in 100,000, I get out this number. And then I keep going and going. And look, as I go to a positive infinity, I'm not getting any lower. Any lower than what number? Whatever the asymptote is. If the asymptote is 50, what's the limit? 50. As you plug in x values that are bigger, 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 your graph just gets closer and closer to what number? 50. We're approaching 50. And that's what the limit is. What number are you guys approaching? You're getting closer and closer to 50 in this case. But you know what? I made this up. This could have been 500. This could be 0. This could be negative 10. It could be anything. Right? Does that make sense? All right. So that is how a limit truly does exist. Okay? As you approach infinity. Oh, you know what? I didn't do the other one, the negative infinity. But that would be just going this way, wouldn't it? Right on top of another asymptote. Okay? All right. In order to approach the second problem of calculus. And by the way, the first problem was the derivative. We did it on your quiz last Friday. In order to approach the second problem of calculus, we must address what happens to functions as the independent variable x approaches negative and positive infinity. So this is what you need to do. Find limits as x goes forever to the right or x goes forever to the left. Here's what it looks like in your book. What's the limit of your function as x approaches negative infinity? What's the limit of your function as x approaches positive infinity? Okay, here is like a formal definition. Okay, I don't think I showed you this, so there it is. If a function approaches a specific number L, okay, hang on, I'm gonna put a number there for you. What's a specific number? If it approaches a specific value 50, let's just throw 50. For larger and larger values of x, then the limit does exist. And it equals what? It says L, but I'm going to throw a 50 at you just because I want to show you what they're saying again. If this number is 50, and that's your horizontal asymptote, well, what they're saying is as you go out forever this way, you plug numbers in, you're going to get this, then this. There you go. What are you getting really close to? 50. There is a limit. As x approaches infinity, you're getting a number 50. But on the other side, how about negative infinity? Well, if you guys remember this from chapter 2, usually what you got was this. Usually you got this one. What am I approaching as I get to negative infinity? 50 again. Yeah. So it doesn't matter if you ride on top of 50 or if you ride below 50. You're approaching 50. Okay? Everybody okay? All I'm saying is this is how a limit does exist. It reaches a horizontal asymptote. Okay? Okay, have you copied that? Did I delay long enough? Because that's what I was doing. I was trying to delay. And if you didn't copy that, then you must really, really get it, right? And by the way, the 50 is not what it says. It just says L. Okay? If you approach a specific number L for larger and larger values of x, then the limit does exist. The limit is L. Okay? All right. Now, is this truly obvious or not? I wrote, of course, but maybe it's not of course. Somewhat. Some functions, of course, don't exist. See that function, 2x plus 3, as x approaches infinity? Of course it doesn't exist. Why? Why of course? Corey says it's a line. Okay, so what? It's a line. Never hits an asymptote. Okay, so Corey, this line has a slope of 2, has a y-intercept of 3, and there it goes at a slope of 2, right? If I go to positive infinity, the bigger and bigger and bigger I get with the x values, what does the y value approach? Is it approaching, as Corey says, a horizontal asymptote? Are we getting closer and closer to an asymptote? No. All you're ever going to get here are bigger, 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 bigger y values. You're not going to get anything, any one number. Okay? So does it make sense? Of course. Linear functions are not. How about parabolas? Are parabolas going to have limits when it comes to infinity? Up, 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 up. All they do is get bigger, bigger, bigger. No, parabolas won't either. All right. How about negative infinity? If I go this way, am I going to bottom out here, guys, and hit an asymptote? No. So, of course, linear and quadratics don't have limits when it comes to infinity. Okay, how about this one? And by the way, you should be going in your head, possibly this one. Now, here's the deal. You come up with the answer. Okay, go. I'm going to call one person's name, and you got to give me the limit. Hint, hint, there is a limit. And then I'm going to ask you, how'd you get that limit? Got enough time? Or no? Maddie, you don't seem like you're thinking anymore. You seem pretty relaxed. What is the limit?
0.
She says 0. Are you confident?
Yeah.
Like 100% confident?
Like 100%.
Oh, 100% confident. Good. Now here it comes. Ready? Here's my question. How do you know?
I graphed it.
Okay, she did it graphically. Did you graph it or did?
No, I graphed it on my paper.
Okay. So then, how'd you graph it?
Well, I just would plug in a number for x.
Okay, like what?
Plot it like 1,
Okay, 1 goes in,
and then you get 1,
and then you get 1.
and 2, and you get 1/2.
Okay, and then did you do 3?
Yep, 1/3.
1/3.
But then if you try to do 0, it doesn't exist. So the asymptote would
So
be
0, 1 over 0 is an asymptote, right? Like that?
wouldn't it be horizontal?
No.
No.
No. X. If you let x be 0, where's the answer? Up there? No. Down there? No. There's no answer. It's vertical. Okay. But now keep going. You said 3.
Oh, well, it will never touch 0 either on.
Yeah. See, there is a horizontal asymptote here. 4, 5. You get 1/5, 1/4. And guys, if you went to positive infinity and you tried 100,000, what's 1 over 100,000? It's a little bigger than what? Just a tiny bit bigger than 0. So you're right on top of the x-axis. By the way, the x-axis, there's an equation for it. Y equals 0. You are approaching 0. She didn't. She got it graphically. Oh, by the way, what if I would have said negative infinity? What's the answer now? As x approaches, wait over here. Negative infinity.
0.
Still 0? Okay, you know what the graph looks like on the other side? Put in -1. What do you get? -1. Put in -2. -1/2. Put in -3. -1/3. What's it doing on this side? Where's it riding now? Just underneath 0. So you're approaching 0 on the bottom side. Here you're approaching 0 on the top side. Okay, she got it. Okay, did anybody do it this way? Did anybody just say, I'm not gonna graph it. I'm just gonna make a quick table. Did anybody go like this? Maybe in your calculator, you just used your calculator to do, something like that. You can type these into your calculator. Just type in, something close to infinity. Of course, it's hard to get to infinity because it really isn't there. But, you can type in all these. Oh, by the way, this is error. Okay, so this would be 1/10, and this would be 1/100th, 1/1000th. And you can see you're approaching what? 0. You're getting closer and closer to 0. So you didn't have to graph it. You could have just made a quick table and said, look how close I am to 0. And you know it's going to get closer and closer. Okay? All right, here's a quick theorem or just something for you to think about because really, guys, we don't want to graph this stuff, do we? Do you want to graph? I don't. Do you want to make tables? No. So here's how we're going to simplify it, and here's how we're going to actually work these problems. Okay, quick theorem. If A is a real number, by the way, A is right there. Real number, you know what I'm telling you? Just don't make it what? Imaginary. You can make it anything you want. 1/3, 1/5, square root of 5. Or you can make it really easy. 2. And R is a positive real number. See this? What they're saying is the exponent is positive and it's real. Okay, what's the limit going to be as x approaches infinity? They're telling you what? 0. It's 0 automatically. What if we approach negative infinity? Oh, it's 0 again. Now here's the deal. I don't want to just tell you that. Can I show you why? Will, can I show you? Yeah? Okay, keep your eyes open, Will, because this is going to blow you away. See that A? That A has to be positive real. Or sorry, no, sorry, just real. Give me a real number. Make it easy. 2. Okay. 2 over, see that x? That doesn't change. See the r? It's got to be positive and real. Make it easy. 3? Okay. Colton says 2 over x cubed. The limit is going to be what? As x approaches infinity. What's the limit? It says it's what? It says it's 0. Is it truly 0? Let's just try a couple problems. Let's let x grow. Let's let it grow. Give me a number we can let x be. 1 cubed. What's the answer? 2. Okay? So far we're at 2. Then let's do 2 over... Get bigger than 1, guys. Okay, let's go a little faster.
5.
5. Okay. 5 cubed. Guess what? Now you get 2 over what? 125. Okay, that's 2. Now you're already down to 2 over 125. You all should know that number is very close to 1. Very close to 0. Now if I do one more, we tried 1, we tried 5. Well, we're going to positive infinity, so what if I try this one? Let's just throw in 1,000. You're going to cube it. Well, that would be 2 over 1,000 times 1,000 would be 1,000,000, and 1,000,000 times 1,000 would be... Oh my goodness, look at that mess. You got 1 billion. What am I really close to right now? 0. I just proved it to you guys. The limit as x approaches infinity is always going to be 0 if you get this look. This look will always pump out an answer of 0. You okay with that? How about if I would have done negative infinity? Then all these answers are what? Aren't they going to be negative? Negative 2, negative, negative. But that all those numbers are close to what? 0. So the answer is 0 again. Okay. Now, give me another function that follows this pattern. Give me something else. We said 2. Give me something else. Any real number. 7. X to any real positive. Now I don't care what you do. 23rd. Guess what? The limit, no matter what, as x approaches infinity or negative infinity, will always be what? 0. You can trust me on that. Because it's just, we could do this all over again, but we just do what? We would just get numbers so close to 0. Now how does this help you? Watch. Here's how it helps. When you do a problem, what's the limit as x approaches infinity of this function right here? Now, do you guys remember in 12.1 when I said, here are the properties of limits, there are 6 properties, and I did property 1, property 2 with you, and I said, the other 4, you go read them. Did you read them?
No.
Okay. One of the properties said this. If you take the limit of a number minus a number plus a number minus a number, you can split those terms up into individual limits. So you could do this. What's the limit of 2/3 as x approaches infinity minus what's the limit of 4 over x squared as x approaches infinity? So what I'm trying to tell you is when you see the limit of a term plus a term minus a term, just do each term individually. There's one up here that's really easy. Which one's really easy? The first one or the second? They're actually both easy, but the second one's easy because we just did it. If you put infinity, which means you put big numbers in for x, this would just become 4 over billions and trillions, which is really 0. The limit of 4 over x squared as x gets bigger and bigger is 0. What's the limit of 2/3 as x approaches infinity? Say it. Because I did this problem with you in 12.1. Now don't say it that loud because that's too loud. I can't hear it. Come on, guys. What's the limit?
2/3.
2/3. 2/3 minus 0? 2/3. Well, by the way, I think some of you are going, I didn't know it was 2/3. Why is it 2/3? If you look at the graph, just look at the graph. See this function 2/3? Remember, that's f of x. Y equals 2/3. Well, here's 1. So 2/3 is about right here. Y equals 2/3 is a horizontal line, forever this way, forever that way. If you went to positive infinity, here's positive infinity. Every time you go up, you hit the same number. What's the same number? 2/3. You and I actually did this in lesson 12.1. Whenever you get a constant, what's the answer? 2/3? 2/3. If that's 5, that's 5. If that's 20, that's 20. Okay? You get the constant answer out. Okay. Are you okay with that? Next one, here we go. What's the limit of 2x squared minus 3 over x squared plus 5 as x approaches infinity? Go ahead, Frankie.
2.
You say 2? Okay. Frankie says 2. Frankie, how? How'd you get it?
If you divide each number by x squared,
Okay.
the x squared on the 2 cancels out to be 2,
Okay.
and the x squared underneath cancels out to be 1.
Okay.
And then the other two terms will be over x squared, and you can't, that would be 0.
Okay. I agree. How did you know that?
I already did this assignment and I used the book.
Oh, so you read it.
Yeah.
She's already read it. Okay. Well, that's great. I'm glad you read it. I'm glad you can understand it. But you know what, guys? You might not understand what she was telling you. Here's what she's trying to do. She's trying to get every one of these terms so that they look like this. This is what she's trying to do. She's trying to get like 3 over x squared because she knows the limit as x approaches infinity of this problem would be 0. That's what she's trying to do. Now, she read the book though, and that's great. Because guess what? Frankie, you're not going to college next year, but that's a great lesson for the seniors, because seniors, when you go to college next year, read the book before the teacher talks to you. Because then you know what the teacher's going to say before the teacher says it. Okay? That's a secret in college. Read before you get to class. I know that's weird, but you have to. Okay, Frankie, why'd you pick x squared? I got to ask you that now.
Because that's the largest x term in the denominator.
Ooh, you read well. Good job. All right, here's what you do, guys. You divide. This is how you tackle these problems. Divide by the highest degree term in the denominator. Okay, I will put this in a box for you because if you don't do that, you will get this wrong. I said denominator, I did not say the numerator, all right? What you will do, divide, oh, I forgot to say something to you, sorry. Divide each term by the highest degree term in the denominator. Now look at the denominator. You got an x squared, and you got, this is x to the 0, by the way. So the highest degree term is what? X squared. And by the way, it's not the coefficient, it's just the x and the square. If it would have been x cubed, I'd divide everything by x cubed. So here's what I'm going to do. I divide every term by x squared. So 2x squared divided by x squared minus 3 over x squared over x squared, and 5 over x squared. I know this looks like a lot of work, but this is what you do, and I'll show you why in just a second. Okay, tell me now. What's this when you reduce it? 2, isn't it? Minus. Now this over this does not reduce, but that's okay, because you're going to take the limit of that later. Okay, this x squared over x squared reduces to what? 1. plus this over this does not reduce. Okay, so here's what you have. You have 2 minus 3 over x squared over 1 plus 5 over x squared. And you're trying to find the limit as x approaches what? Infinity. Now just do direct substitution, guys. Direct substitution, put the biggest number you can think of in for x and for that x. What would the limit be? 0, right. Isn't this going to be 3 over a billion trillion something? That's just 0. So these numbers in the back are just 0, 0. What's the answer? Frankie said 2. Frankie's right. It is 2. Now what did I do? I picked the what power of x? Highest power of x. Where did I look? In the denominator. Don't look in the numerator. Okay, look in the denominator. All right, you have one more to do. Do it. Do this one right here. Oops. Do this problem. Come on over here. All right, there you go. Try that problem. What's the limit of x squared minus 3x over 3x squared plus 5 as x approaches negative infinity? What are you dividing each term by? Look in the denominator. It's whatever the highest power of x is. 2x squared. So divide each term by x squared. That's all you got to do. Do it 4 times and let's see what happens. Help. What's x squared over x squared? 1 minus. Help. 3x over x squared. 3 over x. 3x squared over x squared. 3 and 5 divided by x squared. Yeah, I don't know that one. Okay. Okay. You know what you're doing. You're substituting what numbers in? Negative infinity. So start substituting in negative 10,000, negative 50,000. Well, all that's going to do is make this number approach what? 0. This number also approaches 0. Final answer? What's the limit? 1/3. And if you don't understand what just went on, you should draw yourself a quick picture. Because here's what just happened. You approached the horizontal asymptote 1/3. This must have happened, just so you know. You must have had something that went like this, or maybe this. Somehow you approached a horizontal asymptote. You did. It was 1/3. You don't have to draw this, but this is you drawing it because you want to know what that answer even means. You're approaching 1/3. You're going to bottom out at 1/3, or you're going to top out at 1/3. Okay, last problem. Go. Do it. This is it. We're done. Anybody know what you're dividing each term by? X what? Squared. Did anybody pick x cubed? Because you saw the highest power of x is 3? Don't do it. It's in the numerator. We want denominators. That's all we want. Okay. So do that. So, if you simplify this mess, and it is kind of messy looking, that is what? 4x followed by that, followed by what? 2 minus, that doesn't reduce. And you're trying to find the limit as x approaches, say it. I can't remember. Infinity, positive, okay. Was it negative? It really doesn't matter, because it just doesn't. As x goes forever that way, negative 10,000, negative 20,000, what does this number become? 0. This one, 0. So really, it says 4x minus 0 over 2 minus 0, which gives me 4x over 2, which makes what? 2x. So what's the limit as x approaches infinity? What's the number? I won't say it. Okay, no one's going to say it. Give me a number. Some number. 2. 2 times 2 is 4. Okay, now give me another number. Get me to infinity. 5. You're going really slow. How about 5,000? 2 times 5,000? 10,000. Okay, let's do 100,000. 2 times 100,000? 200,000. Am I gonna eventually bottom out and plateau off? Why not? Because it's a linear function. You guys were supposed to say that's linear. If that's linear, linear functions do not reach horizontal asymptotes. What did you say in this problem? Does not exist. If you ever get something like x, that's linear. X squared, that's quadratic. X cubed, that's cubic. All those functions, up, down, they don't ever bottom out. There's no horizontal asymptotes. Okay? That's the lesson. We have 4 slides for tomorrow. Tomorrow's actually pretty short, and the assignment's pretty short, so not a bad lesson.
When we started that problem, we divide by 2x.
No, don't divide by the coefficient. Divide by just the x. X to what power? You know what I mean?
Yeah.
So ignore the coefficient. Okay? So really, it's either going to be divided by x, x squared, x cubed, x to 4. Okay. All right. I got to correct Olivia's quiz, and then I'll hand the quizzes over. Nope. Then, let's start with you handing out everybody's quiz. Wait for you. What is that? Extras?
Period 5,
Oh, I give you,
Darian.
oh. Who didn't get the quiz back, anybody? Everybody got it? Okay, okay. Olivia did not get it, so give me a second, Olivia. Okay, here's. Here we go. And that's Darian and this is all fifth. Here's fifth. So this needs to be recorded. All of them, sixth. Okay, and then fifth, fourth. Okay. So here's 4, 5, they've got 6. My grade book is right there. Okay, and then here is Jessica's, right?
Yep.
Okay. Jessica. Yuki. Now, when it comes to this again, all the assignments are really in these folders.
Okay.
6, 4, 5 here, or something. Is there? Okay. Hey, I gotta tell you something. When you go through this, be careful, because like Mandy, she gave me all 3 times, followed by page 100. Well, that's something that I want to focus just a little bit. I don't want you grading it.
Please excuse the interruption for a few short announcements. The girls' soccer game today at Fargo Davies has been postponed to this Friday. Practice will be indoors in the main gym, with varsity starting at 4 and JV at 5 o'clock. Girls' softball will be practicing in the new gym at 4:30. And girls' soccer varsity will have their end-of-season coaches survey in room 107. Thank you.
So when you get on that, you need that
Original?
3. I think I understand that.
So I
Right, there's no.
and then he gave me
And you stick it over here. But there's gonna be a mishmash of some, you're gonna see some called ones in there, have 2s.
Okay.
Are you corrected those?
Did I correct him?
No, no, I'm only one there.
Okay.
Matter of fact, this can be going, I already gave her, I already gave her.
It was already, I didn't start.
But all I'm saying to you is, just be careful because sometimes they give you, now they're starting to give you 2 or 3 at a time.
Okay.
How's that sound?
Good.
Okay, good, then, let's do this.
On
1. This is gonna be, you know, they need to, this is really the important, 3 plus 8 and perhaps 3 plus 8 plus 1. They should show you the conjugate. Maybe a step or 2, and then 1, 4.
Okay.
So 1, 1, 1, 1, that's 2, 4. And this one, they are plugging x plus h squared minus x plus h to 4.
11.
Minus this function. This one's gonna be really, it should be a lot.
Only one.
This is called the rim, that's like the final goal. So they get 1 point for this, right? Then they have to set it equal to 0. Okay. So they get this set equal to 0.
How many do that?
Now, the derivative ones that get 2, and then understand that you plug 2 back into the function to get this point. Most of us put a number back and see this.
I don't have a C on
So this would be 1. So that's 6 points, right? Okay. Take it out to 10.
It's like enriched, but we have like the same book and stuff. We just.
The assignment
just
itself
like,
should be quite
yeah.
It's
Just
3 days.
kinda touches on.
So you don't think, you know, here's the old assignment.
I'm sorry.
Well,
I don't know, let's see.
You feel actually-
I share
percent.
on a regular basis.
That is
So-
so nice.
Yeah.
Good?
Mr.
Yeah.
Carlisle.
I don't know. What's your out?
All right,
Like, I didn't even ask, I just did it.
okay, get rid of those quizzes, go.
I gotta do
I don't know what you
this
mean.
fast.
Right on. Molly?
Oh, Mass Donnelly?
Yeah. That's,
Oh,
oh,
here.
sorry, that's not right. I meant AIDS. No,
Well,
it's
for
not.
this class, did you purposely do all the
No, I just wanted to know.
It's probably because they took it.
Okay.
test
When
grades?
Mrs. Kwame put it in
Oh,
Hey, your quizzes, I need them except for, yeah, that's it, right? Okay, your quizzes, bring it back up. Yeah, Kwame put in one, she didn't put in two.
Okay.
So give me time. There's two.
Okay.
Then, if anybody comes looking for me,
Yep.
I'm in, I don't even know. This is Jones's class.
Alright, I'll tell Mrs. Jones pass it up.
You know where it is? It's first floor is this hallway, it's not the first one. Go back to the room straight. First floor.
Okay.
Between
Oh, Mr. Weiser?
one this one.
Okay, the one before Mr.
Yeah.
Weiser. Okay.
Minima, divine, this is round one.
Okay.
Okay, your quizzes, I need them. Hannah, you. You what? Oh, did you show your work on a new sheet of paper?
No, I had it on the plate.
Okay.
How is it? I just didn't know if it was copied on the plate.
What?
Can they help me?
Okay, now here's the deal. You said 0 over 0. But 0 over 0,
I have to solve it,
yeah, it means there's a limit, you gotta keep going.
right?
Yeah. And I think, I don't know what you did here, does not exist. Did you get 0 over 0 again? And then you said it doesn't exist? Yeah, you gotta keep going, factor, factor, cancel, cancel, you know what I mean? And then this one is the conjugate, multiply by the conjugate, okay? All right. Okay, Gabby, you okay?
Yep.
All right.
How long will the slides take?
Slides, before slide, it's more of a, not long, it's just more of when everybody says they get it.
Okay.
It's more of
So
just,
when do you think I can take the quiz after that? Because I can't stay for 7 tomorrow.
okay, how about today?
I'm not
We're not ready. I can get you started. I'm thinking it takes,
Tomorrow?
I'm thinking it's gonna take a half hour. Okay. 25 minutes for you. But,
I can stay for about 10 minutes after.
Colton, I think we're gonna finish.
Probably finish it. Okay.
Yep, I think
Sounds
so.
good.
We'll be fine. Hey, grab, oh, sorry. Grab it. You need a pen, anything?
No, I shouldn't be.
Okay, I got a whole bunch of stuff over here. Okay. Oh,